Welcome to Maths with EJD. Again, I continue with a structured problem that involves the use of assumed mean. I think this is the first time the idea of assumed mean is coming up in this in our statistics classes, so to speak. So we have something like that today, and then we are going to see the advantages and disadvantages of median as a measure of central tendency or location. All right, so let's take the first one. We have three ages. The ages in years of some children in a big family are given as follows. Ages and in years and number of children. So people aged 3 to 7 years, they are three. 8 to 12 years are three. People aged 13 to 17. So you have more of teenagers in that family. There are 10 of them. 18 to 22, they are three. 23 to 27, just one person. So that's what we have there. So you want to use an assumed mean to find the average age of the children. So the first thing we want to do, um, okay, uh, so A now is want the to find the average age of the children using an assumed mean. Okay, of course it's grouped data, so we have to unpack that. Um, so age and number, right? Say, or better still, we know age can be said to be is X, while the number of children can be is simply frequency. Okay. So we can use that. And then we have X to be 3 to 7, 8 to 12, 13 to 17, 13 to 17, 18 to 22, 18 to 22, and then 23 to 27. So that's X. So the frequencies now will be 3, 3, 10, 3, 1. So F is 3, 3, 10, 3, and 1. So that is the basis of the question. So now what we want to do will determine what exactly we need. For instance, first of all, we always need the midpoint, right? We need the midpoint or class mark. The midpoint is also known as the class mark. So since it's something we are just doing ourselves, so let's call that small x as opposed to the big X that we had before. And just like you know already, that is like um 3 plus 7, 10. You know, 3 plus 7, 10 divided by 2. Let me do that. The first one is 3 plus 7 divided by 2. That's 5, right? So this should be 5. And then you have 8 plus 12. 8 plus 12 is 20 divided by 2. That's 10. So you can already see that it's just a 5 gap. So you may not have to worry about the rest because you know automatically this is 15 because 13 plus 17 is 30 divided by 2. That's 15. And of course, this will be 20 because you know 18. I mean, once you see the first two, you can already know what the rest will be. And this is automatically 25. And that works because 23 plus 27 is 50 divided by 2. That is 25. So we have X like that. Now that all of that is sorted, then so we can now take an assumed mean. So we can say uh let the assumed mean, let the assumed mean be A equals 15. You know, you're just assuming. So it can be anything at all. You can choose whatever you like as your assumed mean. Okay. Anything you like can be your assumed mean. So feel very free. But I think it's always good. It's something that falls within there. But you can pick anything for that matter. Like that. So once you pick an assumed mean, so the essence of the assumed mean is that you are going to, so here now I've picked this one as my assumed mean. All right. So you have to pick one of this or something in that line. I could have picked 17, it doesn't matter, right? But if I pick 15, it can make my work easier because after getting an assumed mean, the next thing you want to do, you want to find the deviation of the assumed mean from the actual mean, right? So you want to find the deviation, and that deviation is simply the deviation is simply x minus your assumed mean. All these x's we have here minus assumed mean. So assumed mean is 15, don't forget. So x minus that. So for the first one, that's 5 minus 15, that is minus 10. 10 minus 15, that's minus 5. 15 minus 15 is 0. You know, if I've picked something else, the value here wouldn't have been 0. And when you have 0, your work is sort of easy. Then 20 minus 15 is 5. 25 minus 15 is 10. So if you pick something else, it will be, you get other values, but you still get your final answer. But by making it this, picking something in the middle, you can have this kind of easy spread, minus 10, minus 5, 0, 5, and 10 easily. And once you have that, the next thing you need is to compute the frequency multiplied by the deviation. So next we need FD. Okay. We need the product of the frequency and the deviation. So that is okay, how do I do that? Let me do this. 3 times minus 10, that's minus 30. 3 times minus 15, minus 5, that's minus 15. 10 times 0 is 0. 3 times 5 is 15. 1 times 10 is 10. So, and once you have that, right? So you now need to sum. So we need to, we are looking for, the actual question is, we want to find the average age of the children using an assumed mean. So what you now need is to find, you need the summation of F. Summation of F is 3 plus 3, 9, plus 10, 19, right? No, 3 plus 3, 6, plus 10. You can see simple things can become really tricky when you're under pressure. So you have to be very sure and double check. 3 plus 3 is 6, 6 plus 10 is 16, 16 plus 3 is 19, plus 1, that's 20. And then you also need the summation of F multiplied by D. I mean, from the look of things, right, that's going to be some, could it be negative? Okay. Oh, okay, I get it. I get it. That's okay. It can be whatever actually. So minus 30 minus 15. Of course, you can already see that. I mean, if you want to do, you can see minus 15 and minus 15 already cancels out. That's neutralized. So minus 30 plus 10 is actually minus 20. So it's fine if you get minus 20. So you can now say that the average can be found. So when you use an assumed mean, the formula is different for average. The average is mean, don't forget. So it's just a change of word. The average can be found using, x bar equals the assumed mean plus the summation of the frequency times the deviation divided by summation of frequency. That is how to find assumed mean in that case. Okay. So and of course, you already know assuming is A, summation of frequency. Okay, I can just list all of those out for the sake of it. Um, so A, we took that to be 15. Summation of FD is minus 20, and summation of F itself is actually, is it 20 also? I think it's also 20. It's 20 also. Yeah, it's 20. So summation of F is 20. This is 20. So we can now say, therefore, you know, X, the average is equal to the assumed mean, which is 15, plus summation of FD, that's minus 20, divided by summation of F, which is another 20. So that X bar is equal to 15 minus 1, because minus 20 over 20 is 1, is minus 1. So X bar is equal to 14. So with that, we get the average age of the children in the large family, right? So you can say, therefore, the average age of the children, the average age of the children is 14 years as the average age. The average age is 14 years. So we have found that. So using as in mean, what is the average age? So we found that. So the next thing is to find the median of their ages. So this is first part of that now. The next thing, we want to find the median of their ages, still under A. Okay. Um, so Roman figure to find the median, of their ages. So in this case, we don't need a class mark. So again, let's go. We have X to be 3 to 7, and the frequency corresponding to that is 3. Then we have um 8 to 12. Again, the frequency is 3. Then we have um that's again 3 3 10 3 1. Okay, 3 3 10 3 1. So we have 13 to 17, that is 10. Then 18 to 22, that is 3. And then 23 to 27, that is 1. Okay, so that is frequency in this case. So we are looking for median, right? Uh, and one thing we do for median is this. Okay, so pay attention that this is here. We have to be careful with what the F looks like. Okay, this is small f. Okay, because we still need the. Okay, fine. We need median, right? The formula for median is simply this. Um, Median. Maybe I think I should have written the formula first, but it's okay. Median is equal to lower limits of the median class, lower limit of the median class, plus n over 2. That's like the median mark. I think we can say n over 2 is the median mark. I think I'm going to label all that. And this is actually, uh, well, let me call it the cumulative frequency, CF. This is the first time I'm using that. I've always been using big F before, but that's the cumulative frequency. And then this is the small f multiplied by the class width. So let me list those things out again. This is lower, well, I think this boundary and limit thing, it gets alternated, but I like to call it limit. So this is of lower limit of median class. So it means you need to identify the median class first. Very important. Then this is n over 2 is the median mark. If you allow me to use that word, it's median mark. Then CF is the cumulative frequency. And when we say something is cumulative, it means it is adding up. So you have frequency and then you have cumulative frequency. And then this is actually that is okay. This is cumulative frequency before median class, actually, before median class. So everything refers to the median class. So we have to first of all identify that. And this is median mark because it n over 2 helps us to identify where the median class lies. Okay. So f itself, this small f now, is the frequency, the actual frequency, not the cumulative now, frequency of the median class, frequency of the median class. Then, of course, this guy, H is the class width. It's the class width. So that's the range of each class. That is, subtract the smallest from the biggest, and you get the class width. Mm, okay. Um, so let's go and do that. It means we need the cumulative frequency now. So let's go for that. We need cumulative frequency. That's like the key thing here. So for cumulative frequency, what that simply means is you have frequency here. So 3 is 3 here. So the next thing is 3 plus 3 gives you 6. Then 6 plus 10, you have 16. 16 plus 3, you have 19. And 19 plus 1, you have 20. That's how the cumulative thing goes. Now, from all that now, we need to first of all identify the median class. So we can say the median class is located at n over 2. And n over 2, n is actually the cumulative frequency. That's more, I can even do that. Cumulative frequency over 2. Cumulative frequency is 20 divided by 2. So the median class is the cumulative frequency of 10. The median class lies where the cumulative frequency is 10. It doesn't have to be exactly 10, right? But anywhere 10 is so up to this point you have 6. But you can see inside there you have 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So automatically this is the median class. This is the median class because the 10th cumulative frequency is in this range. So we can say so the median class is 13 to 17. The median class is 13 to 17. Okay. So this is the median class now. So since we now that we have found the median class, we can get L. So L is 13. That's the lower limit of the median class. Then we need, okay, n over 2. We already have n over 2. N over 2 is 10. Since the total cumulative frequency is 10, then we need the cumulative frequency before the median class. So cumulative frequency before, maybe I should even call this CFB actually. Cumulative frequency before the median class. That is, the median class, cumulative frequency at the median class is 16, but before it, the cumulative frequency was 6. So CFB is actually 6. Then what else do we need? We need cumulative, we need the frequency of the median class. Now, this one is not cumulative. Now, the actual frequency of the median class. So the median class is 13 to 17, and its frequency is 10. Okay. So the actual frequency of the median class is 10. Then the class with H is, I mean, it's regular, right? 3 to 7. So the class width will simply be 7 minus, now this is a bit tricky now. What do I do here? This is a bit tricky. When we have 3 to 7, should it be 3, 4, 5, 6, 7, or 7 minus 3, 4? I think I've always done 7 minus 3, 4. So let me just do 7 minus 3, 4. So please, anybody listening to this, follow whatever you're taught in class, because this can be really, sometimes people subtract, sometimes you just count. But since I've been subtracting all along, the first class is 3 to 7, for instance. So I think that should be 7 minus 3, or 12 minus 8, which is the same thing. 12 minus 8, and that is 4. The other approach would be to say 3, to count from 3. So you have 3, 4, 5, 6, 7, or 8, 9, 10, 11, 12, that, which would be 5. But here I've been subtracting, so I just take it as 4. So be sure you do it according to what you're taught in class. I think that's really important. Very important. So please pay attention to that. Okay. All right. So we can go for the median now that we have all this. We can say therefore median is equal to L. Okay, let me just write the formula again. I just like to write formulas because formulas show you how to move times this, and all of that, all of those things we have already. So L is 13 plus n over 2 is 10. The cumulative frequency before that is 6. That's CFB. Yeah, CFB is 6 divided by the cumulative frequency at that class itself is 10 multiplied by 4. Please pay attention to this 4. Pay attention to this because some people can say it is actually 5. Like when you count, when you count 3, 4, 5, 6, and 7. And then you have 1, 2, 3, 4, 5. And then H is 5. But I'm going to use 4 here. I'm just using 4 because I'm just subtracting. So be careful to do it exactly the way it's done in class. Okay, so median now. Median is 13 plus 10 minus 6 is 4. So you have 4 over 10 times 4 over 1. So this is median. Median is equal to 13 plus 16 over 10. Okay, that makes it pretty easy to compute. So median is equal to 13 plus 1.6. So that means the median is equal to 14.6. If we had used 5, right, that would have been 4 times 5, 20. That would be 2. So 14.6 and then 15, they are really close. So, but I mean, just be sure you do how you are taught in class. That's really important. Do it exactly how you're taught in class. Really important. So you can say the median. Okay, let me change the color here. Therefore, the median of the ages is 14.6. And there you have it. Now, talking about median, the second part is asking us to state 3 advantages and 2 disadvantages of the median as a measure, right? So let's talk about that. So the B part, B, talk about the advantages and disadvantages of median. Okay. Okay, perfectionism is a problem sometimes. So advantages and disadvantages of median. Yeah. Okay, or should I say the median, like we've been told, the median. So let's start with the advantages. Let's start with the advantages, the bright spots. The advantages of median. Advantages. Okay. So the first advantage is that it is resistant. It is resistant to extreme values. It is resistant to extreme values because the median is just the number lying in the center, basically. So it doesn't matter the extreme values. So it is resistant to extreme values. That's a nice advantage. And that means that the median is not affected, is not affected by outliers. But you remember the mean is affected by outliers. So the median is not affected by outliers or extreme values or extreme values. Providing, so it provides, so providing a more accurate representation, a more accurate representation of central tendency, of central tendency. It's a measure of central tendency together with mean and mode. So it's a more accurate representation of central tendency in skewed distributions, in skewed distributions. And you don't forget that for normally symmetric distributions, the mean, the mode, and median are exactly the same. Okay, so it's resistant to extreme values. That's one advantage of median. Then another advantage is that it is simple. It is simple to understand and calculate. Probably this should even have come first. Simple to understand and calculate. So I think it's about okay. Well, I mean, let me not make that assumption because the mode can be simple to just count the highest frequency and you're good to go. So, like that, especially yeah, for group data you need formula, right? But for ungroup data, you just count the most frequent and you're good. So, so it is simple to understand and did I say code? Wow, am I so used to code that I turned calculate to code? Chai. So to understand and calculate. So especially in ordered data, once the data is ordered, you can easily find it. Finding the median is straightforward. Finding the median is straightforward. Finding the median is straightforward and does not require complex calculations. Okay. So another advantage is it's applicable to ordinal data. So even for ordinal data, uh, median is good to go. So three, it is applicable. It is applicable to ordinal data. So the median can be used with ordinal data where the mean may not be appropriate. So we cannot calculate mean for ordinal data. So for instance, in a race, right, you have first, second, third. So while you may not be able to compute the mean, you can simply do the median because automatically if you have first, second, third, the median is simply the second. If you have first, second, third, fourth, fifth, the median would be the third, right? So but then you cannot find the mean for ordinal data. So that's one advantage it has over mean. Okay, so let's go ahead. Like you cannot find the mean for ordinal data, but you can find median because median is found by just arranging what you have and taking the center value. So let's move on to the disadvantages. Okay, let's talk about the disadvantages. We've talked about the advantages already. The disadvantages of median disadvantages. Okay, let me start with, okay, we have only two for this. So let's start with this. Well, the median ignores data distribution because it's just arrangement and picking the center value. So it ignores data distribution. Okay. So the median does not consider the actual values, does not consider the actual values of the data. That's where the mean has power over it. The mean takes everything into consideration. So the median does not consider the actual values of the data. It considers only the position. Consider only the position, which can result, in a loss of information. A very good example is if you have, say, you have numbers 1, 3, and 72. Anyhow you look at it, the median is 3, the median is simply 3. But 72 is a significant number, but 3 is representing it. That's such a big deal. So, but it is what it is, like they say. Okay, so yeah, it ignores data distribution. So two, we have that it is less suitable. It is less suitable for large data sets. So if you have large data sets, it becomes pretty difficult to find. It is less suitable for large data sets with grouped data. With grouped data. So when you have something like this, it's not as easy as you might want it to be. So when dealing with large data sets, or grouped data, finding the median requires additional steps. It requires additional steps. Okay, like what we did before. Now, when you have group data, if it is on groups, you can easily arrange and then pick one. But just like what we did up there, finding the median requires additional steps, like calculating, like calculating cumulative frequencies, just like we did up there, like calculating cumulative frequencies. Well, though not that difficult, but I mean, it's adding an extra layer of computation. So we can say which can be more complex, you know. And with that, we come to the end of this particular question. If you have not subscribed to this channel, be sure to do that because you have a whole lot to learn. I'm sure you're learning a lot already. So subscribe, hit the notification bell also so you can always get alerted each time a new video is released. Then comment. Let me know if you wanted to solve a problem or treat a topic. And of course, like and share so that more people can have access to this learning. Okay? Till I see you again, have a very great time. Keep crunching the numbers. Bye.